Alright, so for cotangent, let's think about what cotangent looks like. You guys should know this. You should know that cotangent has an asymptote right there, and it has an asymptote right there at pi. Right? It has a period of pi. Now, if you know the asymptotes, you can figure out everything else. Okay? The middle is going to be the x-intercept, or the midline intercept. And then you're going to have a point right there at 1, and you're going to have a point right there at -1. And you could also figure this out if you actually plug in points and look at your unit circle. Okay, but if I was graphing, this is all I would think about. I would think, oh, this is the shape of my line, and this is where my points go. So this is the regular cotangent function. Okay, now let's see how everything changes. Now the thing I really like about cotangent functions is if you find the asymptotes, you can graph it, no problem. So my asymptotes are at 0 and pi. My graph is between these two. All you have to do is take what's inside of cotangent and put it right here. Pi over 4x minus pi over 2. And then you solve for x. And if you do this, you find your asymptotes. And the rest of it's downhill. Okay, so let's see. We add pi over 2 to both sides, so we get pi over 2 right here. And it's pi over 4 times x in the middle. And then on the over here, we would add it to 2 pi over 2, which is the same as 1 pi, and you get 3 pi over 2. The next thing you would do is you divide everything by pi over 4. When we do that, remember, you're multiplying by the reciprocal. So if I multiply this by the reciprocal, it would look like this, with the 4 and the pi on the bottom. The pi's would cancel out. They would both equal 1. And then the 4 and the 2 would become 1 and 2. And so on the left side, we have 2 is less than x, which is less than, and what will we get if we multiply this by 4 over pi? Well, the pi's would cancel out. The 2 would become a 1, the 4 would become a 2. What do you get? 6. Okay, so these are my asymptotes, the 2 and the 6. I can write that in because I think it asks for the asymptotes. Oh, it asks for the asymptotes down here, so I'm not going to worry about it yet. So for my asymptotes, I have 2 and 6. Now these units, they stink. So I'm going to allow you guys to go ahead and change those because, yeah, I don't like that either. Change it to just 1, 2, 3, 4, 5. It'll make your life a little easier. So we chose 2, 4, 6, 8 instead of counting by pi over 2. So we have an asymptote at 2 and 6. So we put an asymptote right here and right here. So that means we could also have an asymptote right here and right here. Whoops. We just have to go by 2 every single time. In fact, that's our period too. If you didn't know what the period was, you would take pi over 4 and you would divide 2 pi by pi over 4. Oh, you're right, thank you. Pi. Sorry. Okay, so now it would look like this. Pi times 4 over pi. The pi's would cancel out, you'd be left with 4. So your period is 4. Which makes sense when you look at our asymptotes because the distance between each of these x values, between 2 and 6, is 4. What's our phase shift? Okay, now the phase shift, you guys can look at different ways. I'm just going to look at this. You see this asymptote right here? Normally it's on x equals 0. But this asymptote is at 2. So it shifted to the right 2. You guys got that? So we're going to say positive 2. Oh, we didn't finish doing the graphs though. Let's do the graphs. Now the graphs this is the best part because you just have to go in the middle of the 2 asymptotes. And then you need 2 x values right there and there. Now normally, you see right here, between the midpoint and the asymptote, it goes up to positive 1. Is this one going to go up to positive 1? How do you know? because of this number right here. This is the A. We don't call it the amplitude, except you guys want to. That's okay though, because that's the same for sine and cosine. The cotangent doesn't really have an amplitude, but it does the same thing. It's going to change this from a 1 to a 1/2. And so we would put a point right there and right there at positive 1/2 and negative 1/2. So we connect the dots like so, and we got our graph. And I'm going to do dots for the rest of them. Connect our dots. And this one only has one right there, so you can only see that part. This one has a dot right at 1/2, at 0, and negative 1/2, and so I graph it like so. No, that's right. Wrong. That goes down here. So now that our graph's done over here, this stuff isn't that bad. Some of you guys are actually taking -3 and plugging it in. That works. But check it out. -3. Look at -3 right here. Where's -3 at? -3 is right there. That goes down to negative 1/2, and so I just put a negative 1/2 right here. Look at positive 3. Positive 3 is right here. It goes up to positive 1/2. Done. Okay, now let's look at the x and y intercepts. Remember, we're only looking at the interval from 0 to 2 pi. That's from 0 right here to 2 pi. Wait, where's 2 pi on this? Oh crap, there's no 2 pi. What is 2 pi approximately? 6.28. Okay, so it'd be right about here. So we just go from this part to about this part. Okay, do we have any y-intercepts? Yeah, 0, 0. Do we have any x-intercepts? 4, 0. Identify the asymptotes. Done. We did that right up here. Well, we graphed it right here, but we found the asymptotes up here. We have an asymptote at x equals 2. And that's it in that interval. Actually, also, I mean, that's right. It was from here to here. We also have the x equals 6 as our other asymptote. X equals 6. Okay, so now let's take a look at the bottom part of this this problem. Okay, now here we have to come up with our formula down here, our function. We have to find the a, the b, the c, and d. So let's start with the a. The a dictates how far above, like if this was, okay, so this is our tangent graph. There's our asymptote, there's our asymptote. The tangent graph would go right here. Whoops. Let's see, make that better right there. And right here it goes up to 1, and right here it goes down to -1. Okay, if there is a number right here, a, that is not equal to 1, then that's going to change where these dots go. Like take for example, if there was a 3 right there. No, let's not do a 3 since that's in the problem. Let's do 2. That would make this dot go up to 2, and this dot right here go down to -2. So then you would connect the dots like so. Okay, so it kind of like makes the line not as curvy. And if we look at these right here, these two lines, the x value that would give you the 1 and the -1 would be 1 and 3, because those are between the x-intercept and the two asymptotes. So if I look at the 3 goes up to 3 right there, and the 1 goes down to -3. That means our a equals 3. Okay, now let's look at the period. To do the period for a tangent function, you just have to know the distance between the two asymptotes. And it looks like the distance here is 4. So what does b have to be in order to have a period of 4? What does b have to be in order to have a period of 4? Well, for tangent, we know that it's pi divided by b. Well, we need to have the period equal 4. So we just we set it up algebraically. This is how I'm going to choose to solve it. You can probably do it in your head if you understand it well enough. And I'm going to cross multiply, so I have 4 times b equals pi, and then b would equal pi over 4, and so that's what I would put right here, pi over 4. Okay, now we have the horizontal movement, which is the h. Normally for tangent, it's the x-intercept is on the 0. This x-intercept moved over 2 spaces, and so if it moved over 2 spaces, what would this be right here? Well, we can't just put a 2 right here, a -2. We can't do that because we have a b. So because there's a b, I encourage you to think of the tangent function like this, with the b outside of the parentheses, and then put your -2. Okay, the -2 will move the graph to the right 2, so I'll have a phase shift of +2. And then you would multiply this out to get it back into this form, and so you would go 2 times 1/4, which is pi/2. And finally, the last one, to find our d. This does not shift up or down, so that means the d is 0. So just put a 0 right there, and that's how you find that function.